Yes, folks, once again we meet with the part 5 video of this miscellaneous exercise chapter 5. The problem that we are going to take up now, it is they give us a function log x raised to log x and they ask us to find the derivative. This is nothing new to us. We know that whenever you have a function raised to function, it is prescribed that whenever you have a function raised to function, you should always take logarithmic differentiation. So it's a logarithmic differentiation that is going to come to your rescue. So what you're supposed to do is first take the logarithms on both sides and then take the derivative. So let's gradually proceed and see how we can do it. First, taking log on both sides. So you're getting log y to be equal to log of log x raised to log x. Now we've learned that log of a raised to m is m log a. So like that, the exponent comes on this side and you're left with log x. Why we get this is actually by the property log of a raised to m is m log a. It is this property which helps us to get this. So what happens is log y is actually a complicated function, rather it's a product of log x and log x. So we as beginners, we won't be able to do it directly. So we will go in for substitutions and we will check how the substitutions are going to help us to do this problem. So at the very outset, let's call u as log x and let's call v as log x and let's see how it is going to help us. So let's make the substitution. Let u be log x. And what is going to be v for us? V is going to be log x. So let's work with this. It's quite easy for us. U as log x, you can find out the derivative. U with respect to x is 1 by x. That's quite clear to us. Then we can move in for the v value. We also need to find out dv by dx. Now, if you carefully look, v is actually log u, if you carefully observe. As a result, we will go on to check what is dv by du. So the derivative of v with respect to u, we all know is 1 by u. Why? Because it's a log function. But that's not what we require. We require dv by dx. So let's quickly get back to dv by dx. How do we get dv by dx? Because of our chain rule, we always know that dv by dx is dv by du into du by dx. So that way, we have 1 by u into du by dx, which is 1 by x. So you have dv by dx, you also have du by dx. So now let's visualize log y as u into v and then let's go in for the derivative. So let us check now how the derivative can come. Log y is for us u into v because of our assumptions. So as a result, if you plan to take the derivatives on both sides, so derivative of log y and derivative of uv. So derivative of log y is 1 by y dy by dx. And derivative of a product is going to be u into dv by dx plus v into du by dx. Let's see how we can sort this out. 1 by y dy by dx can stay as it is, and u for us is actually log x, and dv by dx for us is 1 by u and 1 by x. 1 by x, u means it's log x. So that's your first term. About the second term, we have v, which is log x. So let's have this log x. And then du by dx, which is 1 by x for us. As a result, you will observe that in the first part, the log x, they can cancel each other. And we are left with, therefore, 1 by y dy by dx becoming equal to just the 1 by x. The 1 by x in the first part, and in the second part it is log x by x. As a result, you could have your dy by dx when the y goes on the other side, that is log x raised to log x. Why? Because the y has moved to the other side, and then this is 1 plus log x by x. That's it. So it's by logarithmic differentiation. First we get the logs taken on both sides, apply the property, do sufficient substitutions, get it as simplified as possible, then revert back to the function and see what the dy by dx comes, and dy by dx is this. So that's all for this part. With the next problem, we meet in the next part. Thank you.